So I typically actually talk about observability, but today I'm going to be talking about understanding vector databases. So show of hands of anybody who's ever heard of vector databases. Cool, most of you. And then how many people feel like you're an expert in vector databases? Raise your hand. All right, I'm only seeing a couple of hands. Cool. Well, for a while, I kind of thought of this as a buzzword, and now I've kind of learned some things about it. So, hi, I'm Jessica Garson. You can find me most places on the internet at Jessica Garson, and I'm a senior developer advocate at Elastic. And so when we think a little bit about what do vector databases do, I like to start with just showing an example of a very simple RAG application, or just kind of a generative AI application. And really, pretty much all of the generative AI applications that we've seen on this stage so far today have used vector databases in one way, shape, or form or another under the hood. But really, to put this into context, I like to start with kind of what we think of as traditional classic search. So when we search for things in Google, we typically just search, we say what we want, and then we get results back. But we're now moving more into a semantic approach. And semantic means not literal matches. So rather than list the keywords for everything you need, you're actually describing what you're trying to get done. And so one way I like to think about this is to think about Star Wars. So can anybody tell me what the well-known sentence of this scene in Star Wars is? Yeah, those are not the droids you were looking for. I heard a lot of people say it. So I'm going to talk a little bit about Elastic for a second. So if we look at a code snippet from Elastic's DevTools, this is basically our classic way of searching. We store some tokens, and then from here, we can actually kind of take a look at what's happening. So we added in an extra HTML tag to make it a little bit more interesting, but what it does is it is extracting the tokens and words that are most relevant and storing them. So from here, we can actually take out the HTML tags that we added, take out the period. From here, we can lowercase everything. And then from here, we could filter out the stop words. So we're down to droids you looking. And then we can use the snowball filter to take out the S and the ing, so we're down to droid you look. And so what's happening behind the scenes is that everything is inside of an inverted index, and it gets a start offset and an end offset. And the inverted index will have a list of all the tokens that it's ever seen, and that's what makes search so fast. It's token-based, and you could tune it through adding synonyms, tweaking queries, and that's really how search has been working for a really long time. And there's some pros and cons of this approach. The pros are that it's fast and scalable and easy to understand, but the cons are that you need to define synonyms, so you'd have to say machine equals droid. There's some issues with homonyms. It's hard to get image and audio search, and user intent is just really hard to capture. Also, it's really hard for question and answering, and for like extracting meaning from longer questions. But it is very scalable and fast, and it works well for a lot of things, and it's been good enough for the long term. So this is where vector databases comes in. One, it allows you to implement a semantic search, and this allows you to kind of get that meaning from your text. And then also, it's really great for similarity searches for images, audio, and video, and it basically allows you to get relevant context of your data, relying on machine learning to encode your data and apply generative AI to create more human-like experiences. So that makes it a really great fit for RAG applications and other ML-type applications. So you might be wondering, Jess, what is a vector? And a vector, that is a mathematical representation of data, like a word, image, or document, as a list of numbers. So a vector database allows you to quickly find similar data through the use of vector embeddings, which is a form of vector data representation that converts words, sentences, and other data into meaning, or into numbers that capture the meaning and relationships. So really, they leverage a machine learning model to translate documents into numbers, allowing you to perform vector searches. So the way that I like to think about it is you have your images, your audio, your text, and you can use a machine learning model to add vector embeddings. And then from there, that gets turned into a vector representation, which is just a kind of an array of numbers. And then your query, that also gets turned into a vector. And then you can actually, or a vector representation rather, and then you can use a search, or you could run a similarity search such as approximate nearest neighbors to find the result. And that's really kind of what happens. So rather than just extracting tokens for search from one input type, you have various input types, and you can extract information through a machine learning model that represents what you have in an array of floats or bytes that you store. And really, this is just kind of the beginning of what you can do with vector databases. If you're interested in diving in deeper, all of the slides from today, all of my code that I've written for various different examples, this is typically a 45-minute talk, so there's different examples, different things like that that you can find, and I have some resources for further learning as well if you're ready to dive in deeper. Thanks so much for having me today.